In this lesson, we will become familiar with all the properties of exponents. So please simplify A through D, and we will check them together in class tomorrow. So I will start with filling out this table right here. This is exponential form, and exponents are connected to bases. So see that little 3 right there? That's the exponent, and the base is the number or letter it is connected to. So it is connected right to the x, so in this case, our base is x. What's that -2? Well, that -2 has a separate exponent. Its exponent is 1. It's not there, but we know it's a 1. So the other base is -2. So if we write this out in expanded form, we have 1 -2, and then since the exponent's a 3, it means we have 3 x's. We could use dots to represent the multiplication, like up here, those asterisks, or we could use parentheses. So let's look at the next one. We have this 3 right here, and the parentheses around the 2 and the x means that that 3 is connected to all of that. So our base in this case is 2x. And just like they have parentheses around it right there, I'm going to copy the parentheses right there. How many negative signs do we have? Just the one out front. So to write this in expanded form, I have 1 negative sign, and then since the exponent's 3, I have 3 2x's. 2x times 2x times 2x, like that. For the last one, we have the exponent of 3, and everything inside the parentheses is considered the base. So -2x is the base. We have 3 of them, so this will be -2x times -2x times -2x. So remember, when you are evaluating exponents in the calculator, the parentheses make a difference, whether they're on the inside or the outside. So let's try a few more. I think you can handle 1a. It's going to be very similar to that one right there. I'll do 1b, and I'll show you how to do 1c. So in 1b, we have 1 negative sign, and this little 2 is just connected to the a. So it means we have 1 negative sign, and then a times a. For 1c, we have a couple different bases. We have this number 2. Its exponent's a 1, so we just have 1 of them. We have the y. Its exponent is 2, so we have 2 of those. And then everything inside these parentheses has an exponent of 3. So we have x minus 3 times x minus 3 times x minus 3. You can check 1a with your partner in class tomorrow. These next 2 properties are pretty special because they help cancel things out pretty quickly. Anytime you have 0 for an exponent, the rule is that your answer always equals 1. No matter what your base is, if the exponent's 0, it simplifies to 1. So a to the 0 power is 1. 500 to the 0 power is 1. All of this inside the parentheses is raised to the 0 power, so it all equals 1. Now for negative exponents, you can never leave your final answer with a negative, so no final answers, because you need to do something to make your exponents positive. What you do is you move whatever the base is that has the negative exponent, you move the base to other side of the fraction bar. If you don't have a fraction bar in your problem, then you just write one underneath whatever your base is. That's the first move. Then you make the exponent positive once you move it. Make exponent positive. So let's try that. We have a to the -2. we can't have an exponent that's negative. So I'm going to move the a to the other side of the fraction bar. Right now, this is really over a 1. We don't go around writing that all the time, but it's there. So instead of the a to the negative second being on top of the fraction bar, we're going to move it to the bottom and make it positive. What are we going to put on top since there's nothing there? Well, we need to fill in a 1. So that's as much as we could do. On the next problem, we have a 4 on top. The 4 doesn't have a negative exponent, so it's going to stay right where it is. This a to the negative 3 on the bottom, it needs to move from the bottom to the top. So we'll move it and make it positive. What's left underneath the fraction bar? Well, nothing really, except for a 1. You don't have to leave your answer like that, though. You could just write it as 4a to the 3rd. So let's try some. Number 2a is going to be very similar to the first example I did up there, so I'll let you try that. Go ahead and try it. Hopefully you move the 2 to the bottom, made it positive, and it simplifies to 1/2 for your final answer. Now let's do 2b. So the first thing I see is an exponent that's 0. 5 to the 0, that equals 1. What happens to this? Well, all of this is on top of a fraction bar right now. So that 1 is going to stay on top. And this 3 to the negative 1 is going to move underneath and become positive. So we have 1 over 3 to the first, which is just 1 over 3. Go ahead and try 2c and 2d. Hopefully you recognize, despite what was inside all of those parentheses, your final answer was 1. And for this one, you may have had 1 over 2 to the 3rd. You moved the 2 underneath and made the 3 positive, but you can actually simplify that even further because 2 to the 3rd power, 2 times 2 times 2 is 8. So 1 over 8 is the final answer for D. Here are some more rules for when you multiply, divide, and raise exponents to exponents. So a product of power means that when you have the same base, like this, A, and they have a time sign in between them, that means product of powers. What do you do with the exponents? You're going to add the exponents. So a to the 3rd times a to the 2nd is a to the 3 plus 2 is 5. How does that work? Here's a little side example for you. We have A, that's 3 A's, and then we have 2 more A's. Well, how many A's is that all together when you count them up? It's 5. So there's the rule. Quotient of powers means that we have divided the same base. So maybe you write a little divide sign there. This would be when you multiply same bases. So we have A and A. A's on top, A's on bottom. These are being divided. The rule here is that you subtract the exponents. And since the order matters for subtraction, you'll always subtract the top minus the bottom. So we have a to the 5th and a to the 3rd. We will do 5 minus 3, which is 2. So that answers a to the 2nd. Here's a little visual of why that works out. A to the 5th means we have 1, 2, 3, 4, 5 A's on top, and a to the 3rd means we have 1, 2, 3 on the bottom. Whenever you have the same thing on top and bottom, they cancel out. So those A's cancel out, those, and look what we have left. A times A, which is A squared. Now let's do this one that has been flipped the other way. The 3 is on top, the 5 is on bottom, so we're going to do 3 minus 5. That is negative 2. We can't leave our final answer like that. We're going to move that underneath the fraction bar and make it positive and put a 1 on top. How does that work out? Well, if we write 3 A's on top and 5 A's underneath it, and start canceling the same thing on top and bottom out, look at, we have 2 A's left and they're underneath the fraction bar. So that's why it's a squared. And then you just fill in the 1 on top. Next we have power of a power. That's when you're going to have something that's inside parentheses with an exponent outside. So see how we have the a to the third inside parentheses with another exponent outside? So there's 2 exponents, the 3 and the 2. What do you do with those numbers? You will multiply them. So this is going to be 3 times 2, which is 6. How does that work out? Well, it means we have a to the third, 1, 2, 3, 2 times. So here's another a to the third. So altogether, that's 6 a's. Moving on to power of a product. That means that we have this rule right here and this rule right here combined. So we have more than one base on the inside with an exponent on the outside. What do? It's kind of similar to what you do whenever you have parentheses and a number out front. You're going to distribute. Distribute the exponent outside to all the exponents inside, and then simplify, whatever you can simplify. So we have a to the first and b to the fourth. We're going to take the 2 and multiply. Whenever you distribute, you multiply. Plus, it's sort of like this power of a power rule where we have exponents on the outside and inside. You multiply them together. So it's going to be 1 times 2, so a to the second, and then b to the 4 times 2, which is 8. You can go ahead and draw out the proof for that if you really want to. It's going to end up being a squared b to the 8th. The last rule takes the power rule and the quotient rule and puts them together. So now we have 2 things, one on top, one on bottom, and they are all raised to the exponent 4 out there. The rule here is the same. You distribute to all the exponents inside and then simplify if possible. So we're going to have a to the second, b to the first. So 4 times 2 is 8, and 4 times 1 is 4. We can't further simplify anything in this problem or this problem because the a and the b are different bases. If these were both a's, we'd be able to keep going and subtract the 8 and 4, but they're not. They're 2 different bases, so we're done. In the first example, I went ahead and threw some regular numbers in there without exponents. I have a 2 and I have a -5. We're going to multiply those together just like we normally would multiply numbers together and get -10. Next we have x's, x to the third and x to the first. This would be the first rule. This is the power rule where we have the same bases. They're both not inside the parentheses, so we don't need to do the power rule. We just have to add the exponents 3 and 1. So this will be -10 x to the 4th. I will do 3c with you, and you can try 3b. So on 3c, I have all of this inside parentheses with a little 2 outside. That means I need to distribute the 2 to all the exponents inside, including the exponent on the 2. And over here, everything inside here, there's the little 1 on the x, is going to be multiplied by the 3 out there. So this will be -2 to the second. Notice how I keep that negative and the 2 inside parentheses. And then it will be x to the 3 times 2 is 6. For the next set of parentheses, it will be x to the 3 times 1, which is 3, and then y to the 2 times 3, which is 6. So I can keep simplifying from here. I know -2 to the second power is -2 times -2, which is +4. I have this base here and this base here that are the same. They're multiplied together. So I'm going to add those exponents. So 6 plus 3 is 9. And I have these y to the 6th over there, and there are no other y's. So that's the final answer. Here are the final answers to 3b and 3d. You do need to show some work in between those, so make sure you know how to get to those final answers.